So very good morning. Today we'll discuss about the topic in the weighted residual method. So see this sum. The following differential equation is available for a physical phenomena, that is d square y by dx square plus 50 is equal to 0. This is the given differential equation. Okay, the limit between this problem is 0 to 10. Okay, they are giving the trial functions. The trial functions y is equal to a1 into x into 10 minus s. Okay, this is the trial function. Okay, this trial function, the boundary condition for this sum is y of 0 equal to 0 and y of 10 is equal to 0. Okay, so once you are, if the trial function is not given in the sum means, okay, you have to assume the trial function. Okay, how you have to assume the trial function means, the boundary condition should satisfy the trial function. Okay, that type of trial functions only you have to choose for solving this physical problem, any physical problem. Okay, you have to choose a trial function. That trial function compulsory that should satisfy the boundary condition. Okay, but this sum, the trial function is already given. Okay, so see here, we have to verify this trial function. Okay, that is y equal to a1 into x into 10 minus x. Okay, so here the x, okay, you have to substitute this boundary condition here. What is the boundary condition given means, once you have to put the x value is 0, the y values are also you have to get 0. Where you have to put the 10 for the x value, the y values get the 0. Okay, so you have to substitute this x here in this equation. Therefore a1 into x value is 0, therefore 10 minus 0. Okay, so 10 minus this 0 is 10. Okay, here is 0 is here, therefore 0 into anything is always equal to 0. Okay, therefore the first boundary condition is satisfied. Okay, you have to apply the second boundary condition. What is the second boundary condition? Therefore y equal to a1, okay, in the x value is 10. Okay, you have to put 10 here, and already 10 minus 10. Okay, 10 minus 10 is 0, so 0 into anything, that is also 0, therefore almost y value is 0. Okay, so the second boundary condition is also satisfied. Okay, so that's why that this two boundary condition is satisfied for this trial function. Therefore you have to choose this trial function for solving this physical phenomena. Okay, so let's see here. Okay, so you have to solve this sum by using that following methods: point collocation method, subdomain method, least square method, and Galerkin's method. Okay, these are the different method to solve this differential equations. Okay, so first you have to what we have to do means, you have to find out the residual functions for this sum. Okay, so how we have to find out the residual function means, you have to differentiate this trial function up to this limit. Okay, you have to differentiate this trial function up to this given physical phenomena. Okay, so this here, so see here, so this is the given trial function. Okay, you have to differentiate this trial function y equal to, you have to multiply this x inside between this bracket. Okay, therefore a1 into 10x minus x square, therefore you have to differentiate this trial function dy by dx equal to a1 into 10. You have to differentiate this 10x, you have to get the 10, and you have to differentiate this h square, we will get the 2h. Okay, second thing, you have to differentiate this, again you have to differentiate this trial function, that is d square y by dx square equal to a1 is multiply with this. Okay, you have to keep like this. Okay, 10 is a constant, you have to multiply, you have to differentiate means you have to get the 0 value. Okay, then 2 minus 2s, you have to differentiate means you have to get the minus 2, therefore finally you can get the value of d square y by dx square equal to minus 2a1. Okay, so this value you have to substitute in the given differential equation. What is the given differential equation? See here. So this is the given differential equation. You have to substitute that d square y by dx square value in this given differential equation. Therefore minus d square y by dx square value is minus 2a1. Okay, and already value is 50 is here. Okay, so this function is known as residual function. Okay, this function is known as residual function. Once you have to solve, okay, you have to solve in any method: point collocation method, subdomain method, least square method, or Galerkin's method. Okay, you have to solve by using any method. First initially you have to find out the residual function. Okay, once the residual function is found out only, then only you have to solve the coming procedure. Okay, also you have to follow the procedures. Okay, first you have to assume the trial function. That trial function should satisfy the boundary condition. This is the first point. And second point, you have to differentiate this trial function up to the given physical phenomena. Okay, so this is the physical phenomena as a differential equation d square by dx square. You have to differentiate up to this limit. Okay, then you have to substitute the d square by dx square value in the physical phenomena. Okay, plus 50, therefore value is minus 2a1. There's minus 2a1 plus 50, that value is called the residual function. Okay, therefore, so first method is a point collocation method. Okay, so you have to find out what is the value of a1. Okay, so r equal to minus 2a1 plus 50, therefore 2 minus 2a1 equal to minus 50, therefore a1 equal to 25. Okay, once the a1 unknown parameters find out means this you have to substitute this unknown parameters to your trial function or approximate function. Okay, already what the trial function is, you have assumed y equal to a1 h into 10 minus h. Okay, substitute this a1 value here. Okay, therefore 25 h into 10 minus h. Okay, this is the final value. Okay, from this you can find out the y value for the any point. Okay, for this is a limit 0 to 10. Okay, so for example you have to substitute the h value. Substitute the h value is for 2.25. Okay, so substitute the 2.25 in the h value. Okay, and find out what is the displacement at this 2.25. Okay, you have to find out what is the displacement at this 2.25. Easily you can find out. Okay, you can find out any. Okay, you have to find out the anything. Okay, from this any points, you have to find out the any point displacement from this point collocation method. Okay, so next one is the subdomain collocation method. This formula to find out the subdomain collocation method is integral of r into dx. The lower limit is 0 and the upper limit is 10. Okay, you would already know about the residual function. Okay, what is the residual functions? Minus 2a1 plus 50. Okay, into dx. Okay, you have to integrate this equation. You have to integrate this equation means what is the value you get means minus 2a1. Okay, there is this is a constant. You have to integrate the one constant means you have to get one h. Okay, therefore minus 2a1 h, and yours another one constant is 50. Okay, therefore 50 h. Okay, you have to substitute the upper limit and the lower limit here. Okay, once you have to substitute the lower limit, the entire value is become 0 only. Okay, therefore no need to substitute this lower limit value. Only I have to apply this upper limit only. Therefore minus 2a1 into 10 plus 50 into 10, that is equal to 0. The finally the value is a1 value is 25. Once you have to find out the unknown parameters, that unknown parameters you have to substitute in your trial function. Okay, that is your trial function y equal to a1 into h into 10 minus h. This is your unknown parameters. Okay, therefore a1 value is 25 into h value is, this keep it as it is, into 10 minus h. Okay, from this you have to find out displacement for the any points in between the 0 to 10. Okay, so next method is the least square method. The least square method, this method requires the integral of I equal to integral of 0 to 10 into r square into dx. Okay, this r square I have to rewrite like this, r into dou r by dou a1. Okay, so this equation we can rewritten like this. Okay, dou I by dou a1 equal to integral of r into dou r by dou a1 into dx. Okay, this is the value you have to get it. Okay, so we know that r value, that is minus 2a1 plus 50. Okay, therefore dou r by dou a1. Okay, dou r by dou a1 equal to minus 2. Dou r by dou a1 equal to minus 2. Dou r by dou a1 equal to minus 2. Okay, you have to integrate this equation, that is minus 2 only you have to get it. Okay, plus 50, this is the constant value. You have to differentiate this equation from 50 with respect to a1 means that is value is 0. Okay, therefore dou r by dou a1 equal to minus 2. Okay, so substitute these two values, r value and dou r by dou a1 value, in this equation, this integration formula. Okay, therefore dou I by dou a1 equal to minus 2a1 plus 50 into minus 2. Okay, therefore this requirement dou I by dou a1 is, that is equal to 0. Okay, therefore minus 2a1 plus 50 into minus 2 into dx, you have to multiply this minus 2 inside this, minus 2a1 into minus 2a1, what is that? Minus 4a1 plus 4a1 minus 50, okay, minus 100 value you have to get it, okay. So you have to apply the upper limit and the lower limit in this sum, okay, upper limit and lower limit. Finally you have to get the value of a1 equal to 25, okay. Therefore y equal to 25h into 10 minus h, okay. The next method is the Galerkin's method, okay. This is the one of the important method to find out the complex problem in the weighted residue. Any complex structural problem, okay, thermal problems, okay, all the problems we can easily solve by using this Galerkin's method, okay. So what is it, Galerkin's method? The formula for the Galerkin's method is integral of 0 to 10, that is lower limit into upper limit, wi into r into dx, that is equal to 0, okay. So here the trial function is y equal to wi equal to a1 into h into 10 minus h, okay. So this is your what is the weighted function means? That is that your trial function is the weighted function, okay. And we already know about the residual functions are, okay, that is minus 2a1 plus 50, okay. So now we have to multiply this term with this term, okay. So finally h into 10 minus h into minus 2a1 plus 50, okay. So you have to multiply this h inside this bracket, therefore 10h minus h square minus 2a1 plus 50, and you have to multiply these two things. Finally you have to get it minus 20a1 into h plus 500h plus 2a1 h square, then minus 50 h square, okay, into dx, okay. Finally you have to integrate this equation, okay. So 20a1 into h square by 2 plus 500 h, you have to integrate this h means h square by 2 and plus 2a1, this constant, and h square is there. Once you have to integrate the h square, you have to get the h cube by 3 and minus 50 h square is here, therefore minus 50 h cube by 3, okay. You have to apply the upper limit and the lower limit, okay. Once you have to substitute the lower limit, the entire value is become 0. There is no need to apply the lower limits. Once you have to apply on the upper limit is enough, okay. Therefore you have to substitute this upper limit, okay. Finally you have to get these equations, minus 1000 a1 plus 25,000 plus 666.66 a1 minus 16,666.66, that is equal to 0, okay. Finally you can get the a1 value, okay. A1 value is 25, okay. Again you have to substitute this a1 value into the trial function, okay. Finally you can get the value of 25h into 10 minus h, okay. So for all the parameters, all the four methods, the parameter you have to get is 25 only, a1 value, okay. For a point collocation method, a subdomain method, least square method, or Galerkin's method, okay. But this will be different for sum to sum, okay. Okay, this sum you get the a1 value is 25, okay. But this value is different from one method to another method, okay. These are all the things are only approximate method only, okay. We are don't expecting that type of exact result in all the methods, okay. There should be some deviations, okay. So you have to get the different answers for this different methods, okay. So this is the actual procedure to solve the sum, okay. First you have to, for a given differential equation, you have to assume the trial function. For the trial function you have to assume that trial function should be satisfy the boundary conditions, okay. Then you have to differentiate the boundary condition up to our physical phenomena differential equations. Then you have to substitute that value into the differential equation, given differential equation, that is our residual functions, okay. Finally you can get the value of point correlation subdomain, least square, and Galerkin's method, okay. This is the procedure to solve the entire weighted residual method, okay. For a few sums the differential equations are not given, they are mentioning in the equation type. For the beam sum, there is simply supported beam is there, the point load is acting at the center, okay. So the length of the beam is L. So you have to find out what is the maximum deflection of the beam, okay. So this type of the general questions they will ask, okay. For that you have to frame that differential equation for the beam sum. Okay, you have to know the bending moment equation, already in the strength of materials, and slope equations, diffraction equation, the rate of loading equations is already available, okay, in the strength of materials. Okay, so you have to verify that and you have to go through it. Thank you.